Alright, for this video we are simply picking it up where I left off in the previous one. We're still in chapter 12, but we're moving over towards a different type of problem. Instead of traveling some distance, we're now going to be doing a certain amount of work. And there's a lot of extra examples worked and a lot of explanation throughout the rest of this chapter. But our problems are basically going to be set up with the use of this ratio here. The number of jobs completed over for a certain amount of time. Okay, so some examples: 3 lawns in 4 hours, 1 paint job in 8 hours, and so on. And so that's the way that these problems are going to be set up. We basically, what we have here is sort of a work rate, and then we have another work rate, rate 2. And if both of these rates work at the same time for the same amount of time, then we can say that they've done they work together. And we can add the two rates and get their rate working together. So as you can see here, the fraction that we're going to equal the sum to is the number of jobs working together divided by the total amount of time that they work together. And so this is how the following problems are going to be set up. There won't be a table as in the distance, rate, time problems. So if we just look at this one example, it says we're crushing cans, and a newer machine can crush 4,800 cans in 30 minutes. An older one, 1,200 cans in 20 minutes. If they work together, how long does it take them to crush 900 or 9,900 cans? So we have 4,800 over 30, and then the other work rate, 1,200 over 20 minutes. We add the two together, and then on the opposite side of the equation we have the amount of work that we want them to do together, and then what we want to know is how long it's going to take them if they're working together. Now these are individual rates working by themselves. The newer machine, 4,800 in 30 minutes. Rate of the older machine, we add the two, okay, to get the total rate. Now once we get it set up, we go about solving these equations the same way we did in chapter 11. Alright, so none of this stuff down here on the bottom is anything that's really new. This is the important part: how to set up the equation to solve these work type problems. Alright, so we'll try our hand at this. Example 12 says we're in an office and there's two different copiers. Okay, there's a larger one and a smaller one. So we have rate of large plus rate of small equals rate together. Okay, and the way these rates are set up, rate equals work over time. Alright, so for the large one we have 240 in 3 minutes. Then we have let's see, the smaller one, 420 in 7 minutes, and that equals the rate together. So we want these two copiers to print or copy 1,610, but we don't know how much time that's going to take them, so we just simply put an X in the place of the time for R together. Alright, what we do at this point is we make a common denominator, and that the common denominator would be the LCD, which would just simply be a 7 and a 3. So this one was missing a 7, so I put it in the denominator and the numerator. This fraction here is missing the 3, of course, and so we multiply numerator and denominator by 3. And so that'll get the denominators equal. We have 21, 21, and then we have 1400 plus 280, so that's 1680, and then we have 1200 plus 60, so 1260. Okay, we got a little more work to do and we sort of run out of room, but now that these two fractions have the same denominator, we simply add them together, and we have 0, 4, 9, and then a 2. Okay, 2940. Alright, so all that's over 21. And on the opposite side, we have 1610 over x. At this point, all we have to do is cross multiply, and we get 2940. X equals 21 times 1610, and I need my calculator for this, so let's see, clear, 21 times 1610, and then what we're going to do is divide both sides by 2940, and we'll get x by itself. So 21 times 1610 is 33,810, and now we divide by 2940. 2940. Enter, and we get 11.5. Okay, so as far as chapter 12 goes, what's really new is our strategy for solving these work rate problems, and that's basically what we do is we add the two different rates and we set it equal to their rate working together. Okay. As far as the equation itself goes, we've already solved quite a few of these in chapter 11, and this just sort of gives us more practice. Okay, the next few problems, our workbook tells us that for instance, in the last one, a copier copied maybe 240 copies in a certain amount of time. The next few problems are a little different, where a lot of the times they work on the same size job and there's only one job. Okay, not really a big difference, but it is a difference nonetheless, and it could throw you off if it wasn't brought to your attention. So we'll look down here at the example they gave us, and it says Eugene can shell a half bushel. Okay, this is 1. Okay, basically we're looking at shelling a half bushel as one job. Alright, and it does Eugene does this in 40 minutes. So if you look down here for rate 1, we see one job in 40 minutes. Okay, then it says his friend can shell the same amount of peas, basically can do the same job, if you will, but he does it in 30 minutes, so he's a little bit faster. And if you look down here for rate 2, we have 1 over 30. Okay, So once again, we have two rates that are added, and then over here we set it equal to the rate total. So um, if they were to work together, this is what we've been calling this, is work together. If they were to work together and do just one job again, shell a half bushel, then we see we have one job, and then we don't know the time that it takes them, and so we replace the denominator with an x. And the workbook has already worked out the equation for us and set it up, and in the end we see that it takes them 17 minutes, or 17.14 minutes. Okay. So as you would sort of expect, if they work together, it doing one job, it takes them less time. So let's scroll down and work a few of them ourselves. Okay, example 13. It says Prentice can mow a 3-acre lot in 5 hours. It only takes Thomas 4 hours to mow the same size lot. If they were working together, how long would it take them to mow the lot? So we have the rate of Prentice plus the rate of Thomas, and we set that equal to the rate working together. And the way you construct each of these rates is you put the amount of work over the time. Alright, and in this case the work is a single job. Okay, they mow a 3-acre lot. This is the one job, because it carries on. It says it only takes Thomas 4 hours to mow the same size lot. So they're doing the same amount of work. And so what we're going to do is just put label the work as one. Okay, one job. So work of Prentice would be one 3-acre lot in 5 hours. Thomas would be one same size job in 4 hours. He's a little bit quicker. And then how much, okay, if they worked together over here on the right and did one 3-acre lot, how long would it take them? X goes in the denominator. So one way to solve this would be to multiply everything by the lowest common denominator. So to find that, we just simply look at each of the denominators and we say there's a 5, there is a 4, and there is an x. Okay, 5 and 4 do not share common divisors, so we need one of each of those. And then there's an x, so one of each factor. And the way we use this lowest common denominator is we multiply everything in the equation, every term, by 20x, the LCD. So our equation ends up looking like this: 20x over 5 plus 20x over 4 equals 20x over x. Alright, but the purpose of multiplying all of these terms by 20x is so that the denominators cancel. And so 4 divides into 20 and leaves a 5. 5 divides into 20 and leaves a 4. So our equation becomes 4x plus 5x equals 20. No more fractions. 4 and 5 combine to give us a 9x, and then we divide both sides by 9, and we get x is equal to 2 and 2/9. Okay, our time up here in the problem, the 5 and the 4 were given in hours, so likewise the 2 and 2/9 would be in hours as well. Example 14 reads, Barbara can type a monthly report in 50 minutes. If she types the report, it takes Glenda 80 minutes. Okay, so Glenda is associated with 80, Barbara is associated with 50. How long would it take them to type the monthly report if they work together? So rate of Barbara plus rate of Glenda equals rate together. Okay, so we for the rate of Barbara, we write one monthly report in 50 minutes. Glenda, one monthly report in 80 minutes, and working together, one report in how many minutes we don't know. Okay, so this is our unknown x, and to solve it at this point, we go about it the same way that we did in the previous example. We find the lowest common denominator, which let me think, in this case would be smallest number that 50 and 80 will divide into 400, and then we also have to include the x because it's in the denominator on the right side. So this is our LCD, 400x, and basically we just take this 400x and we plug it into the numerator of each of these fractions. So 400x over 50, 400x over 80, and then 400x over x. At this point we go back and we simplify our fractions. 80 goes into 400 5 times, and 50 goes into 400 8 times. So our equation simplifies to an 8x plus a 5x equals a 400. 8 plus 5 is a 13. And then to solve for x, we divide by 13 on both sides, and we get x is equal to, let me see what we get. I'll pull up my calculator and actually figure out 400 divided by 13. It's not a whole number. We'll have to round it, I guess. If we wanted an exact answer, which Alex may want you to give an exact answer if you're working these problems in your homework, then use 400 over 13. If it says that you can round it, then maybe you would want to write 30 point, I'll say 77 if we round it to the nearest hundredths. Okay, and this was the unit of time that we were given in the problem was minutes, and so this is going to be 30.77 minutes. And that finishes up this example. So we'll clear that and roll on to the next one. Okay, in this one, it's just pointing out one way we could change the problem slightly. And basically, that is if we were to instead give the time that it takes for one of the workers to finish the job on their own, this one job in 12 hours for the pipe 2, and then instead of giving the time for the other pipe, we give the time working together. Okay, so what's unknown about this problem is how long it takes, let's see, pipe number 1 or 2, whichever one it is, figure out how long it takes one of the pipes individually to fill the pool. Okay, so we don't have to give the time for both of the workers. We can instead give the time for one worker and then the time for the two workers together. And really it's just as easy as setting up the previous examples. The X just goes into a different place, and then you see that we work the equation in the same way. You see that the workbook writes out to the side, multiply by the LCD, and here we see the LCD appearing in each of the fractions. Okay, so they simplify everything. The fractions disappear. You can see that on this line here, and then in the end we get 24 equals X, and the time that we were given in this example was hours. So let's see, the question was how long would it take pipe 2 to fill the pool? Well, here's our answer, 24 hours. Alright, so still the same as the problems in the beginning of the video. Let's read the problem first. Example 15, Miss Myers uses 2 different size hoses. If it takes 40 minutes to fill the aquarium when she uses both hoses, how long would it take to fill the aquarium with the smaller hose? If alone that hose fills the aquarium in 60 minutes. Okay, so we have a rate of the smaller hose, we have a rate of the larger hose, and then we have a rate of the 2 hoses working together. So they're filling the same size aquarium. Okay, you can see that here they said the aquarium, the aquarium. Same job, so we're just simply going to write one job on the top of each of the rates, and then the 60 minutes actually refers to the larger hose, so we're going to put the 60 minutes on the bottom of this fraction. And then it started out telling us that if she uses both hoses, then the job takes 40 minutes. So the 40 is going to go over here on the bottom of the fraction to the right. So here is where our X goes. And this is what's supposedly so different about this problem versus the ones we were doing in the beginning. Now, from here on out, we follow the same procedure as we did before. We find the LCD. Smallest number that 60 and 40 will divide into would be 120. And then we need an X for this denominator. And we go back to our equation and we just simply put a 120X in all of the numerators. At this point we simplify each fraction. For this one the x's cancel. For this one, 120 divided by 60 leaves us with a 2, and then 120 divided by 40 leaves us with a 3, and our equation reduces to a 120 plus a 2x equals 3x. If we gather our x's together on one side of the equation, we can do that by subtracting 2x from each side. And we now have 120 by itself on the left, and on the right we get lucky, and a 3 minus a 2 just leaves us with a single x. So we found our solution, x equals 120. 120 what? We go back up here and we find our units of time, and we were given minutes, and so our x is 120 minutes. This represents the time for the smaller hose to fill the aquarium. okay, because the X was originally on the bottom of the rate for the smaller hose, and X is our time. Okay, example 16, our last example of the chapter. It reads, Coach Mary Wood has 2 crews. Okay, and the first crew, Waldrop's Wonders, can clean the gym in 2 hours by themselves. Then the problem goes on to read, working with, okay, if the Waldrops worked with the Dennis Dandies, and basically this is the word that you have to pick up on. It means together. Okay, if they were working together, then they could do the job in 90 minutes. And the first thing you really want to pick up on here is that our time is in different units. Alright, we're going to work with the hours, and so the first thing we need to do is take the minutes and convert it to hours. Alright, so to get rid of the minutes, we multiply it by our conversion fraction, and to cancel the minutes out, minutes goes in the denominator, hours on the top, and there, for every 1 hour, there are 60 minutes. So we basically divide 90 by 60. The minutes cancels. We're left with hours, and that would be 1.5 hours. Alright, so we were given 2 crews, so we have 2 rates, the Waldrops and the Dandies, and then we have our rate of the 2 crews working together. Alright, so they are cleaning 1 gym. All through the problem, it refers to the gym, and then again it refers to the job, okay, and then the question has the gym. So the job is the same no matter whether they're working together or separately. So we have a 1 on the top of each of our rates, and for the Waldrops, we have their individual time. That would be 2 hours. So we put 2 on the bottom of this ratio, labeled with the W. For the Dandies, we don't know their individual time, but we do know the time that they spend working together, 1.5 hours. That was the time that we had to convert. So 1.5 on the bottom of this fraction. And so what we do here, to make our life easy, we can just simply go through and multiply all of the terms by all of the denominators, the 2, the 1.5, and the x. Okay, and that'll knock out each of the fractions, because that is the whole point of multiplying by the LCD, to get rid of the fraction. So we'll take this and we'll put it on the top of each of the fractions. We get 2, 1.5x over 2, 2, 1.5x over x, and 2, 1.5x over 1.5. So LCD contains 1 of each of the denominators, so in each fraction the denominator is going to cancel, and it leaves us with the equation 1.5x plus 3. Okay, 2 times 1.5 is 3, and that equals 2x. Okay, to solve for x, we subtract 1.5x from both sides. We're left with a 3 on the left and a 0.5x on the right. And to finally solve and get our variable by itself, we divide both sides by 0.5, and we get a 6. X equals 6. So what this tells us is that the Dennis Dandies, the rate of the Dennis Dandies is equal to 1 over 6. Okay, the 6 is the hours that it takes for the Dandies to clean the one gem. Okay, and that completes that problem, and that's the end of this chapter. Thanks for watching.